Hi, I'm Mr. V. This is Illustrative Mathematics, Geometry. We're in Unit 5, which is Solid Geometry, and this is Prisms and Pyramids. So today's lesson, the objective is for you to come out and say, I can explain the relationship between prisms, pyramids and cones, prisms and cylinders. And the first thing I had you do is there are 3 slides. You should try this on your own before looking at this answer. But there was, you're supposed to draw the nets and basically draw what are all the sides, what is the surface area of all the sides when you look at this. And for each of these, I've given a short video which shows what a net is. A net is a 2-dimensional shape that when you fold it up, it could make the 3-dimensional shape that you're looking at. So they're all connected. And you can see I've got a base that's a square, and I've got 4 triangles. They all come to a point up here at the apex. In the next one, this is a prism. It's a triangular prism because the top and the bottom, or the side and the side, the 2 parts that are the same are triangles. And if you look at this, I'll see if I can make this nice and big here. You can see when it's opened, the base, let's see, the top and the bottom are both the same. Those are the 2 triangles. And all of the other parts are rectangles, and that would be true for any prism. The third one, the one that's more challenging to do, and try to do it on your own, this is one that we will be talking about later. And this is where you have, of course, you have a circle for your base. But the top part, when you unfold it, it looks like it's part of a circle. It's going to be what's called a sector, an area of part of the circle. What are the names of the solids? The first one is a pyramid, square pyramid. You have a triangular prism, and you have a cone. And what is the same and what's different about the surface areas? We will talk about that here in a moment. And also the only one that is not a polygon as its areas, and that's going to be the third one, which is the cone. So we had some sorting activities to do. And the first one was when you were to sort this activity into whatever categories that you wanted to. And then you had to explain it, what your rule was for sorting it, and only into 2 groups, not 4 groups, not 3 groups. And then we did this a second time. And some people said, I sorted it into all of the ones with a circle in it, or circle base. And one of the bases is circles, and everything else was not. Some of them did all of the ones that are oblique, or all of the ones that are prisms versus all the ones that are not prisms. Maybe all of the ones that are cones and all the ones that are not cones. So there's a few different ways of doing it. It's not infinite, but there are quite a few. And then at last I had you sort these into the categories that I've got here: cylinder, pyramid, prism, and cone. This would be a prism. You have a cylinder. Even though it's oblique, it's still a cylinder. Prism, cylinder. These others go to an apex, and that's the difference between them. And you can look on this page, and it'll show you how many of these that you have correct as you go through it. Here's a short video which explains the difference between cylinders and prisms and pyramids and cones. And you should watch this. This tells you about how cylinders and prisms have 2 bases that are the same. Pyramids have a base and an apex, or a point that they go up to. That's the big difference. We also looked at some Archimedean solids, and I think I have this open. So an Archimedean solid, there are only 5 of, Platonic solids. There's only 5 of these. They all have to have the same shape for the faces. Those are going to be regular polygons. This is a square for its face, and they all meet at the 3 faces meet at a vertex. And when we do this, there's only 5 of these that exist. If we did it with a tetrahedron, this is with 4 sides. If you took the midpoints of the cube and connected them, you'd end up with an octahedron. And the same thing if you took the octahedron, you took the midpoints of the faces, you would end up with a cube. They call this the cube octo world. Then the next one is the dodecahedron. This is made up of pentagons. As you can see, there's regular pentagons. And there are dodeca, that's 12 faces. All of them are congruent. They all meet, each one of the vertices meets at, each one of the edges meets at a vertex. There we go. If you took the midpoints of these and connected them, you'd end up with an icosahedron. Icosahedron is 12. Let me put a shading into it so you can see it a little bit better maybe. This has got 12. They're all equilateral triangles. And Plato represented these by calling them one water, one air, one land, one fire, and there's one more that he called the elements, the elements. But I just wanted to expose you to these. The real crux of what we did today was building pyramids to make a prism. And here's the link to the handout that I gave. You can print it out or copy it down on paper somehow. I don't know how you would do that without a copier. We had printouts for everyone in the class and scissors, and I had tape, but apparently I only had one tape dispenser, so that was a problem. We were to assemble in the three pyramids into one, and then to upload a picture of it. So you're going to make these three pyramids, and you're going to make it into a prism. And I've got them labeled here. You can see that this is. Let me see if I can make this bigger. You can see it. Oops. You can see I've labeled this P1. I've got P3, and P1 and P3 would actually, when you line these up, see they have the one face that makes the same shape. And if you put that shape as the base, well, they're going to have the same altitude as well. But there's an easier way to see it. I don't know what that is necessarily. Maybe you can see how when I line these up with the same base, how they go to the same height. These actually fit together. And when I add the third one in, let's see, it'll go like this. Oh, here it is. So it'll make all three of these will fit together to make a prism. Notice the top and the bottom are the same. And on each one of these faces, I've got half of a rectangle. So you can see which ones are done. And you can see that I can open this up and I can make this into the three pyramids, the three pyramids. The point that we will be discussing next time we meet is how the three pyramids have the same volume each, even though they're very different shapes. But we can tell that if we look at one face as the base, how they come up to the same height, it means they have the same volume. And if three of them make up a prism, what is the formula for the volume of a pyramid? The volume of a prism is the area of the base times its height. So if it's 1/3 of that, because there's three of them, it'd be 1/3 the base times the height. And that's going to be what we're going to prove. We're also going to show it with a cube. And I've built one of these here. This is a cube, and I've constructed it with three pyramids, three congruent pyramids. These are oblique pyramids. You can see that they go over to the one side. They do not rise up in the middle. And that's so that I can fit them together. And when I fit them together, they make a cube. The volume of a pyramid is 1/3 the area of the base times its altitude or its height. That's the big idea. So you're supposed to make a conjecture about the relationship between the volume of a pyramid and the volume of a prism. And what would you need to verify that? And that's what we'll be doing next time, is verifying it. Some of the questions you marked might want to ask yourself: if I have my first pyramid, and which side is the base? Or does it matter? Can any of them be the base? And that's a really good question. What about if I take 1 and 3? Here we've got pyramids 1 and 3. And are any of the sides congruent? And I've marked these so that they're congruent. And you can see they are the same shape. It's a dilation or a switching around the same. In fact, I think I've just got the one that's the same. Oh, these last two are also the same. I don't know if you can see, but the top and the bottom are the same. So this would be the top. top of the pyramid, the bottom of the prism, top of the prism, the bottom of the prism. And there's the lesson summary. Of course, this is where they make the cube like I just showed you. And the conjecture, the thing we're going to be exploring next time, is that the volume of a pyramid is 1/3 the area of the base times the height. Good luck and success.